All right, let's do this thing. So here is my series, right? I know this is a series because I have this summation. I've got that sigma, that summation notation. So with that summation notation now, I have this series, and here's what we're going to do with it. Part A is find the first four terms of S sub n. Find the first four terms of S sub n. Once I get those terms, then we're going to find an expression for S sub n and make a conjecture. All right, so when we make a conjecture, that's where we're saying, oh, this is what we think is going to happen, right? That's all that means. All right, step one, find the first four terms. This is S sub n. So you get your first term, then you add your next one to it. Then you add your next one to it, right? So S sub 1 means I'm going to take k going from 1 to 1 because it's S sub 1 of 1 over k times k plus 1. Plug that in. 1 over 1 times 1 plus 1 is 1/2. There is my first partial sum. My second partial sum tells me I'm going to go from 1 to 2. So this is this of my sequence here, or my series, sorry. So I'm going to do 1 and 2. I'm summing up 1 over 1 times 1 plus 1 plus 1 over, plugging a 2 in, 2 times 2 plus 1. Do you see what's happening? So 1/2 plus a 1/6. When you look at that, you get your common denominator. So that's going to give me 3/6 plus 1/6 is 4/6, which is the same thing as 2/3. Okay? Do the next one because I've got 4. So S sub 3, right? We can put all this in. I'm summing this up. From k is going from 1 to 3 of 1 over k times k plus 1. But you're seeing this pattern, right? I've got 1/2 plus 1/6 plus, then I'm plugging in that 3. 3 times 3 plus 1. So I've got 1/2 plus 1/6, which we know these together are going to be 2/3 plus this next term. So 3 times 4 is 12. Then again, with that common denominator, if I make this over 12, I've got 8/12 plus 1/12 is going to be 9/12, which reduces to 3/4. Then, now that we've seen this pattern, do you see how this is playing out? We have 1 to 4 of 1 over k times k plus 1. And yes, you can say, oh, I know. This one is happening, so 3/4, that's what the first 3 summed up give you, right? Then I just have to add the fourth one to that. 4 times 4 plus 1. So 3/4 plus, what is that? 4 plus 1 is 5 times 4 is 20. Again with that common denominator. Out of 20 times 5 would give me 15. So this is 16/20. When you reduce that, you get 4/5. I've got my first 4 terms, right? Here's the first 4 terms of partial sequences. It goes from 1/2 to 2/3 to 3/4 to 4/5. All right? There's my first 4 partial sequences. And do you see, we did extra work here, but do you see what's really happening? You could take this and then add it right to that because that's equivalent. Same thing here. You could have just taken 2/3 plus the next one in the sequence, or the next one in the series, and then get your answer, which is what we actually did here, right? Okay, this is just the first one, so I'm just showing you how it is. Now, here's where you'd look at. Remember how I told you that this S sub n just stands for a pattern? Look at those 4 numbers. 1/2, 2/3, 3/4, 4/5. What's a pattern you see? Yeah? And it's just the numbers. So just look at those numbers and come up with a pattern. S sub n pattern. What are you seeing? Yeah, there's one more in the denominator every time, right? So look at this. N over n plus 1. I've got 1, and then 1 more is a 2. I've got 2, 1 more is a 3. 3, 1 more is a 4. You seeing this? Yes, so that's my pattern. That is my S sub n. That's what I'm talking about when I say find a pattern. Okay, now, how do we come up with this value with our S sub n? Well, you take a limit. So I'm going to take the limit as n approaches infinity of n over n plus 1. Yep, same degree. So my limit is 1. If my limit goes to a 1, that means the value of my sequence also converges to that 1. So k goes from 1 to infinity, a 1 over k times k plus 1. This is equal to 1, and it converges. Not bad, right? So that's it. When you have these patterns, you're going to look at the first 4 terms. What is the pattern? And then once you have that pattern, then you take the limit, and that is your value. If your limit diverges because it goes to infinity or whatever you've got going for you, then so does your series. Not bad, right? Yeah. All right, check this out. I'm going to make this a little bit bigger. Oops, not quite that big. We're not going to get too crazy on it. Here is the summary of this section. So remember, this is called an overview. So we have talked about 3 main things. A sequence is an ordered list. A series here that I'm looking at is the sum of those numbers. So just a basic series, I'm just adding up that sequence, adding those numbers up. The sequence of partial sums, however, is used to evaluate the series. So I can take this sequence of partial sums, and that's going to give me the value of my series. That's what we talked about. And of course, this is 10.1, the overview. We're going to get a lot more specific. So sit tight, because super exciting stuff is coming your